assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So for this problem, we are given the scenario of an object that is oscillating back and forth across a specific distance. So it's moving to the right and to the left across a specific distance at which the extremes of that distance, it reaches a point of zero velocity. So our velocity to the right is 0, and our velocity here on the left is also 0. So the object itself is oscillating back and forth between these 2 points. It reaches a 0 velocity, turns and goes in the other direction, hits 0 velocity, etc. Just going back and forth between those 2 points. We are also informed that the time it takes for this to happen, our time, is 0.25 seconds. The time it takes for the object to go from one point of 0 velocity through to the other is 0.025 seconds. And finally, we are also given the information that this distance here between those 2 points, those 2 extremes, is 36 centimeters. We are then asked to find 3 pieces of information. The first piece of information we're asked to find is the period, which has the variable t. And the period is how long it takes for the object to oscillate one full cycle. The second thing we're asked to find is the frequency. How many oscillations can it complete over a 1 second period of time? And the variable for frequency is an f. And finally, the last thing we are asked to find is the amplitude. For this oscillation. So first thing first, period, how long it takes for this object to oscillate from one position of 0 velocity through the center to the other and back again. In order to do one full cycle, the particle has to end up exactly where it started. So one full cycle is the distance there from left to right and then back right to left. We know that it takes 0.25 seconds for the object to go one way, so it would make sense that it would also take 0.25 seconds for it to go the other way. So, given that information, we can say that our period is 2 times 0.25 seconds, which gives us a period of 0.5 seconds. So it takes 0.5 seconds for one full cycle. For our frequency, we need to use an equation. And in this case, the equation is t equals 1 over f. So period equals 1 cycle per frequency, or per hertz. To find, since we're going to be solving for frequency, we have our period right here. We just found our period. We can rearrange this equation to solve for frequency, in which case it would be frequency equals 1 cycle divided by the period. If we substitute in our values, we have frequency equals 1 divided by 0.5 seconds, which gives us an answer of 2 hertz, which is the unit of frequency. Hertz is cycles per second. All right, the final part of this problem is finding the amplitude. So again, thinking about our object, it is there's a midpoint position and it's moving to the left and to the right between points of 0 velocity, and the total distance between those 2 points is 36 centimeters. If we were to take this concept and actually turn it into a graph, where we have displacement on our y and time on our x, and we tracked the motion of this object. If it started in the center and it went to the right, and then it went to the left, and to the right, and to the left, and so on. And we know for a fact that the distance between the two extremes, the furthest point to the right and the furthest point to the left, is 36 centimeters, then we are then able to determine that, okay, well, if this is the halfway point here and the total is 36, then our amplitude, or the total displacement from equilibrium, equals 36 divided by 2, or 18 centimeters. And for consistency's sake with frequency and all of those values, we are going to want to convert that into meters. And so 18 centimeters is the equivalent of 0.18 meters. So that is our final amplitude.